Hey guys, today I'm going to teach you all about simplifying expressions. By the end of this lesson, you should be able to simplify expressions by identifying and combining like terms. We will also learn about different parts of expressions, and that includes like terms. Go ahead and get out your notes and be ready to learn. We're going to go ahead and start out with an example that is non-math related. So on the screen, I've got some pictures of food. Let's say that myself and my husband are going to a concession stand and we're each going to get a burger, a fry, and a soda. When I go to order, I'm probably going to not say I need a burger, I need a fry, I need a Coke, I need a burger, I need a fry, I need a Coke. I would probably combine similar items together and then tell them the quantity of those items. So here you can see I've combined the 2 burgers together, the 2 fries together, and the 2 Cokes together. We also know in math we can use variables, so I would probably even use variables. And then since we're combining these items together and I'm going to order, I would say I need 2 burgers and 2 fries and 2 sodas. So that and would tell us we are adding those together. So this is just an example of what combining terms in an expression would look like without using numbers in math. So now that we've connected this to something that might make a little more sense, let's go ahead and look at our guided notes. At the top it says an expression is a mathematical phrase that can contain variables, numbers, which are constants, and operations. Now we'll use the expression below to label the different parts of the expression. This first part, the -6 and the x together, is called a term. The 12 would also be considered a term. Any of the pieces, like in our last example with the burger and the fry and the soda, the burger was a term, the fry was a term, and the soda was the term, and then we can have multiple of similar or same terms. Next, in this case, the plus sign is the operation. Keep in mind that we don't only have plus as operations. Subtraction would also be an operation. The 12 in this expression is a constant since it is a number by itself. The x is a variable. We know anytime we see a letter in math that those are variables. And finally, the -6 in front of the x is called a coefficient. Make sure that you have each of these pieces labeled on your guided notes, as this vocabulary is going to be really important. Next, we're going to look at actually simplifying expressions. Terms can be classified as like or unlike, and expressions can be simplified by combining like terms. So next, what are like terms? Like terms must have the same variable and base. Bases have to do with exponents, but in this first example, we've got 7x and 9x, and those are like terms because we have whole numbers without variables, or without exponents, and then our variable is the same. The x and the x, those are the same variable. But in the example below that, 4D and 4G, just because it's the same number, the variable is not. I've got a D and I've got a G, so those are not like terms. Next, in the table on the left, we're going to determine which of those terms are like terms. So in the left table, I'm going to look at the first example. I've got 8C, 16, -8C, and -16B. So I'm going to look at the variables, and I'm going to see if I can find any of the same variable. And I see that this first term, 8C, and this term, -8C, both have a C. So that makes those like terms. In the next example, I see 12, -12x, and 12x. So again, I'm going to look through there. I see all of the same number with one being negative, but I only see the -12x and the 12x that have the same variable. In the next example, I have 9y, 5z, and 9w. In that example, none of those variables are the same, so there are no like terms. Next, we have 11g, 11, and -7g. I see that the 11 and the 11 are the same, but combining like terms doesn't really have anything to do with having the same number. What we really want to focus on is having the same variable or the same letter. So I do see that there are 2 terms here that have a G, 11G and -7G. So I know in the first 2 examples we had kind of the same number. They were opposites, 8 and -8, -12 and +12. And just notice that in this example now, we've got 2 different numbers, but what is important is that we have the same variable. I want you to go ahead and pause the video and try the next one on your own. So in this example, I see 0.5t, 1.5t, and 2.5. So again, I'm looking for the same variable, and I see that I've got t and t. So 0.5t and 1.5t are my like terms. Next, we have 1m, n, m, and 1. In this case, I see that there are two letter m's. Those are both like terms, they're just written a little bit different. Anytime I see a variable by itself, that means that the number in front of it, or the coefficient, is 1. So here I have 1m and m. Go ahead and do the next two on your own. In the first one, you should have noticed that we had three terms with the letter b, so those are like terms: 4b, b, and 9b. The last one might have been a little tricky because there were none with the same variable, but any numbers are also considered like terms. We know that we can add together or subtract just regular numbers, so in this case, we've got 0 and we've got -8, so those are like terms. They don't have a variable attached, so they are just plain integers. In the table on the right, we're just going to determine if those examples are like or unlike. We don't have to figure out which terms are like terms because we're just seeing are they like or are they not. In the first example, I've got 29 and I've got 29 squared. So I told you in the beginning when we were looking at the vocab that base had something to do with exponents. The base is the number that is in front of or with the exponent. So in this case, the base is 29. And since they both have a base of 29, it doesn't really matter that one doesn't have an exponent and that one does have an exponent of 2. And the exponent is just that little number next to the 29. So in this case, 29 and 29 squared are like terms. In the next example, we've got b and 3b. That's what we were just looking at. Since they both have the same variable of b, they are like terms. 6 and 9, those are just integers, so those are like terms. In the next example, we have -3r and -3p. I noticed that I have -3 in each of my terms, but that doesn't really have anything to do with the terms being like or unlike. What really matters is the variable, and here I have r and p, and since those are not the same variable, these are not like terms. In the next example, we've got exponents again, but these exponents are just a little bit different. I see that little 2 next to the k in the second term. That is an exponent with the variable, and when the exponent is with the variable, to have like terms, both variables need the same exponent. So in this case, I have 13k and 13k squared. So since one of the k's is squared and one of the k's is not, these are unlike terms. If the terms were 13k squared and 13k squared, then they would be the same since both k's are squared. Go ahead and pause the video and try the next three on your own. The next example is just like the one we did, c and c to the 4th power. Since c has no exponent and c to the 4th has an exponent of 4, those are unlike terms. In the next problem, we have c, 4c, and 8c. Since all of those terms have a c, those are like terms. And finally, we've got 16, 0, and -9. Since those are all integers, those are also like terms. On the back page, it reminds us at the top that only like terms can be combined. Here's another example like I showed you at the beginning, using something other than numbers and letters. This one says the Robinson family ordered snacks at the state fair. They bought the following drinks: D, the pizza P, and ice cream cones C. They're just using variables to represent each of the items so that we don't have to write the whole word out. I'm going to go ahead and start looking for drinks and circle those in the same color. So I see that I've got a soda, another soda, and a soda over here. So it looks like I have 3 sodas. I'm going to go ahead and do that for the other items. Going through the items, it looks like I have 5 pizzas. Finally, I'll do the ice cream cones. Now that I've got them combined, I can write an expression and then simplify the expression. This would help in a situation like this. If I were to go and order snacks, I don't want to give them a long list of food. It's going to be easier on them and me to group my food and then tell them the quantity. So in my expression, I have it written as the way that it's laid out now. Pizza plus soda plus cone plus pizza plus cone plus pizza plus pizza plus soda. But like I said, we don't want to go and actually order it that way. We want to combine them and tell them how many of each item we are getting. Now that I have them combined, you can see that I added together the variables that were the same. So I went through my expression and I found the p's. There were 5 of them, so now my coefficient is 5p. That's like saying pizza and a pizza and a pizza and a pizza and a pizza. That is 5 pizzas. Next, you can do the same thing for the soda. There are 3 sodas, so that is 3s. And then finally, there are 2 ice cream cones, so that is 2c. We do need an operation between our terms, so I used a plus since I'm adding each of those items to my order. I'm getting 5 pizzas, and I'm getting 3 sodas, and I'm getting 2 cones. You may notice that I like to circle and write in different colors the ones that are together. That's a good strategy to help yourself keep them separate if you have colored pencils or highlighters or markers. Next, I want to look at a few of the expressions at the bottom. Let's look at number 1. I've got 7a minus 6 plus 8a. I'm going to show you one way that I usually group these terms together. Like I said, I like to circle and use different colors. So I'm going to go ahead and circle my first term in blue, and that is 7a. I notice that my next term is minus 6. That's a different term since there is not an a with it, so I'm going to use a different color. Notice that when I circle that term, I include the minus sign. That is a negative 6. A minus and a negative are the same thing. When we're combining like terms, I need to keep that minus sign with the number that it's with and make that number a negative. That way when I combine it, I can take that into account. My next term is plus 8a. I notice again that that's another one with an a, so I'm going to go ahead and circle that in the same color blue. Again, I made sure to include the plus sign that was in front of it because that is part of the term. That tells me that is positive 8a. So now that my 3 terms are separated, I have 7a, negative 6, and 8a. And now I can combine the ones that are the same. So I've already color-coded, and I know that 7a and 8a are like terms, so I'm going to combine those to have 15a. Next, I have that negative 6, and I can write this in 2 different ways. I know that since I'm combining like terms, that combine means to add, so I can write it as plus negative 6. I also learned in Unit 1 that adding a negative is the same thing as subtracting, so I could write this as 15a minus 6. Those are equivalent expressions. That just means they are the same. Let's go ahead and look at number 3. I'm going to go ahead and start by circling any of the terms that have the same variables. So I'm going to start with 20c. I see that that has the letter C, and then I'm going to go and look through my expression here and see if I have any other terms with the letter C, and I see that my third term, the plus 10c, includes the variable C as well. Now looking in that expression, I don't see any other terms with the variable C, so I'm going to switch colors and start looking for another variable. I see that in my next term I have plus 8d, so there's a different variable, the variable d. And then finally, my last term in this expression, minus 5d or negative 5d, that is a similar term because they have d. Next, you can see that I've written this combining or putting together the terms that are like. So I rewrote the expression and I moved that 10c to the front with the 20c, and then I moved the 8d to the back with the other minus 5d. And now I can combine the terms that are similar. When I combine 20c plus 10c, that's like having 20 ice cream cones plus 10 ice cream cones, now gives me 30 ice cream cones. Then with the d's, I've got 8d minus 5d or 8d plus negative 5d. Either way, I'm going to get 3d. Go ahead and pause the video and try number 2 on your own. I found that 14b and 6b both had the same variable b, so I circled those together in green and then combined them. 14b plus 6b is 20b. And then I have that minus 12. There are no other terms that can combine with that term, so you just attach it to the end. So I've got 20b minus 12. Remember, we could also write this as 20b plus negative 12. Either way, those are equivalent expressions. We will save 4 through 9 and go through those together in class. Now I want you to pause the video and summarize today's lesson in 2 to 3 complete sentences. Okay guys, that's it. Now you've learned about simplifying expressions. Let me know, do you prefer to call your friends or text your friends? In this lesson, we learned to simplify expressions by identifying and combining like terms. Bye, guys!